Alrighty, welcome everyone. This is week number 11. We're going to be talking about mod number 9. This is going to be there's two mods that actually go, this is the paired module. This is going to be talking about Linux and networking. We'll talk about the basics, and then we'll go into some little more advanced stuff dealing with the networking services and web services. Alright, so what we got going on this week? So, we're going to have a lab. This is going to be a you will not need your computer, your actual instance for this one. The lab is going to go ahead and be right here. It is going to go ahead and have you walk through three different subnetting possibilities. And then you're going to go ahead and explore some protocols, okay? In cybersecurity, you're going to be expected to kind of know some really important protocols. If you don't know, there are 65,535 different port numbers that have been blessed by IANA, as these are going to be all the ports that you can use on the internet, basically. And within those, there are 1,024 what they call common ports, okay? So any port number that's below 1,024 is considered a common port. And these are, and I'm going to say they're common ports because these are a lot. You don't have to memorize all 1,024, but there are a substantial amount of them that you, as an IT person, should memorize, know, and understand. There are a couple that are also outside that you should know and memorize and understand, and you'll get those in this one too. But your job is going to actually go through the actual protocols. Identify the port numbers associated with them, okay? And then give me a brief description about what this protocol is, okay? So, tell me what these are. Just kind of get familiar with them, okay? You will learn these the more and more you deal with them, okay? You're not going to be expected to know them right now, but just know that a good chunk, I would say about 95%, if not actually 100% of these, you should know, okay? And these are just very, like I said, these are very common ports that you should know in IT. They help you with troubleshooting, they help you with being a pen tester, they help you with doing anything that has to do with IT, okay? So that is going to be in the mod. The 9 lab. Again, IS subnetting. Cool. You probably learned subnetting already from Professor Fabius's class. And then we're going to go into the port system, okay? So once you've done that, then you go ahead and do, you have a video. It talks about, it's a nice little video from O'Reilly's conference in 2011. Which talks about IPv6 Day, okay? And it goes into the idea that, you know, we are running out of IPv4 addresses that actually run out. We've already run out. There's no we're running. We are out, okay? And we just talks about the transition to IPv6. We've been transitioning for a very long while, and it kind of goes into what's the holdup? Why is this a problem? You know, this and that. And then you got lab. Okay, so the lab is there. All right, let's get started. So today we're going to talk about networking terminology, network addresses, subnetting, common network ports. We're going to talk about the difference between IPv4 and IPv6, okay? And then look at common network protocols. So networks, okay? So remember, this is their definition of a network. It's 2 or more computers communicate through some sort of connection, okay? That is the most basic way you can explain what a network is. And this actually transcends into our current world. When we go do networking, it is 2 or more people communicating through some sort of event, some sort of commonality, or a conversation. So each person or each computer in this actual network is going to be referred to as the host. Another more common one you'll also hear is something called an endpoint device. Okay, an endpoint device. Two classes of networks. It says two classes. You know that there are other classes. There are other different ones. But this one specifically calls out LANs, which are local area networks, and WAN, which are wide area networks. There are MANs and CANs, which are going to be metropolitan or metro area networks, and CANs, which would be campus area networks, okay? And there's other ones, there's a couple more in there too that they kind of just added in there, but we're not going to discuss that. This is not a networking class, that's meant for networking class. So, data. Data is sent across the network using network packets. And if you are any type of network person, you're going to understand that the term for data changes, or a network packet changes depending on what level of the OSI model you're at. You have packets, you have frames, you have bits and bytes, and it just depends on which one you're at, okay? Each message includes not only the data, but also metadata. And this metadata is referred to as the packet header. So this, again, for some of this is review. So every packet that gets sent has a packet header. And if you think about this, this is like on an envelope. If you receive mail, the metadata would be the stuff on the outside of the envelope, where the data would be the inside of what's being delivered to you. So the packet header and the IP Internet Protocol address and the port and destination host. The IP address is like a street address. Again, port is a numeric value associated with, so here's who it's going to, that's the IP address, and the port number is actually going to be the numerical value. So here's the street, and then here's the actual numerical address, okay? So a router especially determines which LAN to send a message to by its subnet values. The subnet values like the city, state, or the zip code of the letter. And then the subnet value can be combined with IP address to create a unique network address, okay? So a server is a host that offers a service. It serves something to the receiver, which is the client, okay? So the server is a host. Think of it this way: if you go to a restaurant and you have a server, that server serves up your dishes, right? You order food, you put in a request for food. I want to order this 8-ounce sirloin steak, medium rare, with cornichon and a black pepper gravy, mashed potatoes, macaroni and cheese, and a little bit of broccoli, just because I'm trying to make sure I'm losing weight. I am the client. I am putting a request in to receive this food. The server is going to go ahead and say, okay, you want this food. I'm going to go ahead and find where this food is and make sure that the kitchen cooks it and then serves it to you. There you go. Here's your food, client. So that's a really easy, nice way to understand the difference between client and server. Server is something that serves. A client is something that actually requests, okay? And we'll talk about this a little bit more in depth. We talk about network protocols in just a little bit. A protocol is a standard of communication. Again, these are already standards. This is a protocol. What is a protocol? Some protocols are going to be things such as the transmission control protocol. Interestingly enough, it actually has protocol in the name. There's also the UDP protocol, which is user datagram protocol. And then there's the Internet Control Message Protocol, or ICMP, or ping protocol, okay? There are hundreds of standard protocols that we talked about. All right, so IPv4, that's the current standard on the internet, and it's being replaced by IPv6. IPv4 is a dotted decimal notation. It's delimited by periods or dots, and it has an addressing scheme of 32-bit binary numbers divided by 4 octets. Each octet is then converted to a decimal number, and the octet value can be between 0 and 255, okay? So, for example, 204.25.1.16. As it stands right now, there are currently 4.3 billion possible IP addresses. On the other hand, IPv6 is we've been trying to move to it. It's a lot harder than we expected. And the hope is that it can overcome this. So we've switched from being a 32-bit system to a 128-bit system, and this uses hex characters. So from 0 to F. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F. Okay? So 16 hexadecimal, 16 bits. It does give us a larger address pool, multiple trillion addresses, and for every person alive today. Okay? So here's some ideas of comparing both. Again, you know it's 32-bit versus 128-bit. It gives us 4.3 billion with no extra subnetting, which if you pay attention to your networking class, subnetting is taking a large summation and breaking it down to smaller ones, and then it actually is the reverse one. The supernetting is taking the smaller ones and then being able to build it back up into a big one, okay? So this right here is IPv6, and notice it gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, 13. So we have 13 slots out. Okay? Routing for IPv6 is more efficient, is how network packets are moved from one network to another. Our configuration, it can be considered the DHCP, which is Dynamic Host Configuration Protocol, or an IPv4, but without needing a DHCP server. So DHCP is a service that provides a host IP address, which you may experience that a little bit. So you know your IP addresses are leased out to you. They're not like static. In most cases, if DHCP is enabled, you can create a static IP address, which in most cases, a lot of times your servers are going to have static IPs, but an endpoint device will not have a static IP address. Each network package has a header that contains information about the packet. The header is much more flexible, and then secure-wise, IPv4 relies on other protocols to provide security. It's going to be TLS and SSL, and IPsec, and WinSock. Whereas IPv6 already has that security kind of already built in, okay? So why haven't we switched? So first of all, the protocols are very different. It's not a trivial task. It's not very trivial. The protocols are different. The other thing is too is that, so let's say for example, Google switched IPv6. It wouldn't matter because most of the internet is actually IPv4. So what they would have to do is they'd have to do a converter and put a converter up from IPv4 to IPv6 and vice versa. One of the ways we try to go and fix this, we created what's called network address translation. So it allows you to have one-to-many situations. So let's say, for example, you have this IP address here, right? This is the one for your company. Internally, you assign a whole set of private IP addresses, and this is attached to your web server. So any private IP address internally, this is that 172, the 190, the 172, the 192, 127, the 79 or 80 in Class A addresses. Each address, Class A, B, C, have a private IP address that you can choose to be used internally, and they're called not routable. They're only allowed to be routable internal to a network. They are not routable on the internet, okay? So if you have that 204 address, that means you have a one-to-many ratio. So you have one public IP and many non-routable IP addresses, okay? So when they talk and they need to do web requests, it goes directly to that one IP address, and that one IP address handles all the communication. That's network address translation. Same thing that happens when you actually go ahead and if you have Spectrum or AT&T. You have a dedicated IP on your actual gateway. That is a dedicated IP address. Internally, though, you have a plethora of IP addresses. So again, IP address is broken down by 4 binary numbers. Starts with the it's a power of 2. 2 to the first, 2 to the second, third, fourth, fifth, sixth, seventh, and eighth. Okay? That's 1, 2, 4, 8, 16, 32, 64, and 28, 128. If you also get confused, it's double the previous one. So 1 plus 1, 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. All the way up to 64 times 2 is 128. Okay? And then we convert this binary into this right here. The classes A, B, C, D, and E. Yes, there is a D and there's an E. D is for multicast groups and E is for research and development. So, again, A gives us to 126. So 127 actually is go ahead and be, that's going to be the private IP scheme. Then we also have the 192, which is a private IP scheme here. And we talk about subnetting as taking a large network and dividing it into smaller sections or subnets. I'm not going to show you how to subnet. It's because there are so many different ways you can do it. Okay, I'm going to go ahead and just go over it a little bit, but I'm not going to show you because there's multiple different ways. You probably have already been taught several different ways. Okay, so this actually talks about converting everything from ones and zeros. It walks you through how to do that. Private IPs, again, class A is a 10 range, the 172 range on Bs, and then 192, 168 on Cs. These are used with routers that utilize NATing, and again, we talked about that one-to-many situation. Serious and common protocols, we talked about IP, TCP, UDP, ICMP. So IP makes sure that the packets delivered between the hosts. TCP ensures that packets arrive in a reliable and ordered manner. So this is actually the reassurance that you're going to get what you're asking for. These are stateful connections. Okay. UDP is connectionless. When I say stateful connections, that means that they are going to verify that the host got the message and it wasn't corrupted. Okay? And if it doesn't get the message, it's going to then go back to say, hey, I'm missing something. Can you send it to me? UDP don't work like that. UDP is connectionless. So it's going to send you the packet. It don't care if it gets to you. It don't care if it gets stopped. It doesn't care if it's corrupted, out of order. It don't matter. It's going to get to you. And there are purpose for this. Things such as streaming, such as video, VoIP calls and everything else that can tolerate a little bit of choppiness are going to be UDP specific. But things like HTTP are not going to be UDP specific. Those are going to be TCP specific. And you kind of get to feel like, oh, if I'm doing gaming, that's going to be UDP because of the fact that I can lose a couple of packets and still not go ahead and have a problem. It's only when I lose too many packets is a problem. But however, if I'm transferring a file to you and I lose a couple packets, that's a problem. That means that file is incomplete, which means I will not, it's corrupted at that point. Okay, does that make sense? An ICMP is a troubleshooting technique. This is a ping command, okay? Again, here are some services. You can find them on Etsy services to see here. And I can just show you real quick what it looks like on my machine. Let's go Vim, Etsy, or let's do Vim services. Here's the services. These are the well-known or common ports. It's from 0 to 1023 and 1024 to 49151. These are registered ports. And then from 49152 to 65535, these are called private ports, dynamic ports. You're also going to hear them be called random high ports, okay, RHPs, random high ports. And that's going to be the word of the week for attendance, random high ports. So, okay, random high ports, RANDOMHIGHPORTS, random high ports. All right, So again, 2021, I'm already giving you some of them. Here's Secure Shell at SSH. We'll talk about what that is later. File Transfer Protocol is 2021. 23 is Telnet. SMTP is 25. 53 is Domain Naming Services. 80 is HTTP or Hypertext Transfer Protocol. POP3, which is Post Office Protocol. POP3, get it? There actually is a POP2 and a POP1. And that's going to be on port 110. Here are some other common ones. IMAP, POP3S, LDAP-S, Syslog, SMTPS, HTTPS 443, LDAP is 389, SMP, IMAP, NetBIOS or NetBEUI, and NTP. Okay. All right. I have config. We're looking at actually some commands now. Oh yeah, I was going to show you this. So here you go. /services has a printout of all the different port numbers. And again, if you want to search for one, so I'm going to go ahead. I'm going to do a / to search. I'm looking for number 110. And if that's not the one I want, I hit the N key to go and give me the next one. Hit enter and then hit the N key. Oh look, here's all the 110s. More 110s, more 110s until I get to the one I want. So 110. There you go, POP3. And again, like I said, POP2 is 109. All right. So we're going to go ahead and actually look at this real quick. We'll look at so in Windows, to look at your actual IP address, you need to type in ipconfig. And specifically ipconfig space / all because it won't give you everything. However, it doesn't work like that in Windows or in Linux. Linux actually has very similar ipconfig, but for Linux, actually it's called ifconfig. And the reason why it stands for interface. Okay, so we'll go to ifconfig. And here we have our information right here. As you can see, I have my INET, which is my IP address. Okay, this is the name of my interface right here, EMP0S3. That's my interface name. My subnet mask, my broadcast address. If I have an IPv6 address, here it is, right here. Okay, this is how many packets have been transferred, have been received. Okay, in bytes. I've received 164 megabits. I've had no errors. I have dropped 4,023 packets. And then this is how much I've transferred. Okay. This is my loopback address, 127.0.0.1. Subnet mask 255.0.0. Okay. And this is my virtual bridge. Okay. You won't see this. You may see this on your system, but you may not. Okay. It talks about up. Is the interface up? It is up. It is working. It is broadcasting. It is running, and it does have multicast capability. Okay. MTU is the maximum transmission unit. So this is how much it can transmit. It can transmit up to 1,500 bits. Okay. Or bytes. Who's bits? Again, it goes with my IP address, my INET address. And then here is going to go ahead and be some information about, let's see, did they give it to me? Did they have it here? Let me see. Oh, okay, sorry. I apologize. I was just trying to go ahead and make sure. Okay, so I need to go ahead and actually talk to you all about something. So one of the things you're going to have to understand is you're going to have to figure out, well, what kind of computer do I have, okay? So here's the thing to keep in mind. Every computer component has what's called a MAC address, okay? So the network card that I have in my virtual machine, even though it's a virtual machine, it has a network card, virtualized, in here, okay? And that's going to be this guy right here. This is the MAC address. Notice it's made up of 8 hexes. So it's hex all the way up for 8 actual runs, okay? So we have ether right here. Okay, cool. We have ether. So I'll go ahead and do this. The first three, those are called the OUI, okay? The OUI designates the vendor or who made that actual device. So you can do this on your own computer too. I am showing you real quick. I can show you on my CMD just so you can go ahead and I'm going to increase this just a little bit. Nope. Damn it. Sorry. Hate CMD sometimes. Okay. All right, cool. Now let's do ipconfig /all. Okay, cool. So here I am. I'm on my machine. You can see right here. Here's my physical address on my machine, okay? My personal machine. So I'm going to go ahead and do this. I'm going to do OUI. I'm going to type in D8BBC1. So here's a tool called Mac Lookup. And this says that my network card is a MicroStar card, okay? That may be helpful, maybe not. Maybe, for example, if I know it's a Dell, maybe Dells make their own network cards, or, you know, HPs or whatever, you can kind of discern what that is. But here's the important part, okay? Let's go back to my virtual machine, okay? Look at this. It's got an OUI right here. So let's go type that into my actual MacUp lookup. So this is PCS System Tech Link, okay? So let's go over here to this one, my virtual bridge. Let's do that one now. So that one doesn't have anything, but this one does. This one does. And it said that it was associated with this. So that's pretty important because what is this? Well, PCS System Technique. That may not be as helpful, right? But here's where the helpfulness comes in, okay? Let's go ahead and do VMware MAC addresses. So if we're using VMware, okay, for example, my MAC address is always going to be this. The prefix, the OUI is always going to be this for VMware if it's a virtual vSphere workstation or ESX server, okay? If it's VMware, it's always going to be 001C14, always. Now you can change it if you want to, but also these are the ones registered. This is on VirtualBox. Let's go ahead and look at VirtualBox. Let's see. Let's go ahead and see if it gets in here. So we're going to go to, let's come over here. It says we're going to network, settings. So there's my, that's my MAC address for my adapter, okay? Cool. So that's that. So you can use IFconfig to change network settings temporarily. You can make them changes are not persistent across reboots. IFconfig, you can change the IP address, the network mask, the broadcast. You can take it down or put it up, or you can take it into promiscuous mode or take it off promiscuous mode. So you can see IFconfig ETH0 permisc. And how do we figure this out? We can probably check the man page for IFconfig, man IFconfig. Aha, look at that. This is all the information we need. To enable disable ARP, we can go ahead and enable ARP or disable ARP. You do not want to disable ARP. Okay? Do not disable ARP. I know what it sounds like. That if I disable ARP, this is going to be a challenge. Why you should not disable ARP. Okay? To bring a network interface up or down, you turn it off, turn it back on. Do not turn it off on your machine, okay? Especially if you're on the cyber range, don't do it. You'll have to reset your entire machine. So you can actually go ahead and do network manager and is running. You can do the NMCLI device status. There you go. Right there. You can stop it temporarily and it'll start back on once the reboot happens, or you can disable it permanently, okay? So ARP. ARP is the address resolution protocol, okay? So let's go ahead and just actually look at that for just 1 second. I'm gonna go ahead and I'm gonna move to here. So ARP table correlates MAC addresses to IP addresses. So whereas the network attributes an IP address to a MAC address, ARP will go ahead and say, hey, if you want to go to Google, the first thing that happens is your computer's going to do an ARP request and say, hey, who has this IP address? And it's going to send out to the Ether, and Ether is going to go ahead and say, the Google server is going to be like, ah, that's me. It's going to send it back. It's going to hit the web server. It's going to send it back and say, hey, so-and-so has this IP address. You should go there. And that's what's going to happen, okay? So, to test that out, let's actually do this. Wireshark. What's my Ethernet? Okay. So I'm going to go ahead and come over here. I'm going to do a ping. Let's see if it actually captured it. Okay, we did. Okay. So that was UDP. Look at my conversations with you and see if I capture anything that was TCP related. I did. Okay. So let's look at this. 2607. 2004. There you go. And apply this as a filter. Okay, so didn't capture all the way because I think I have something wrong with my actual packet capture for my network device. That's wrong. But so when you actually go ahead and start talking, it's going to go ahead and say, hey, who is so-and-so? And you can do an ARP. So ARP here, you can do ARP TAC A, and it lists, oh, look, these are all the IP addresses that I know of. Okay, you can do the same thing here, ARP. These are all the IP addresses, the hardware, the MAC addresses I know of associated with this specific IP address. Okay, I can display it. I can delete entries. These also will not be, they will not go ahead and stick around long. They will age off. They have to go ahead and let me see if I can. So if they're dynamic, so this is dynamic. So if they are dynamic, they will go ahead and become stale and they'll have to go ahead and redo that, okay, that communication. So routes. So the way this works is you want to look for the G. The U signifies that it's up, it's working. Oh, I can't say it's working, it's up. Because just because it's up doesn't signify it's working. And especially if you are going to networking, you realize that just because it's up doesn't mean it's working. G signifies the gateway. That's an active gateway. And we read this by default. So if the destination is default, then I want you to go ahead and use this with a gateway or generated mask here. If I'm going to 192.168.1.0, I want you to use the default here. Okay? This actually signifies default. I can add a gateway using route add command. I'm not going to add one though. I can delete a gateway route. This actually is what happened to Facebook supposedly when they, right after they had just had the spillage about what their research has been doing. Supposedly someone deleted a route for all of Facebook and Instagram on the border gateway protocol, on the border gateway routers, and they were not able to go ahead and route the traffic to Facebook, so, and Instagram and YouTube and all that jazz. So we can add an IP, a newer command design to replace ifconfig, arp, and route. So actually IP does everything. So you can do IP attack help. Let's see. We can do IP address. Oh, look, there it is. Aha. IP route, IP ARP. Oh, that does not work. What is the ARP command? IP link. IP link. Okay. IP end table. Okay. I've never mentioned the end table before. Emerald, monitor, tunnel, name, M address. Oh, yeah, there it is. IP M address. MAC address. See? Okay. And it talks about that in 304 to 305. You know how to use that. Host name. The host name gives me the host name of the specific box. My host name is called that. You can also find this in the etc host file or an etc host name. Okay. You can change your host name if you want to. But however, if you use it during the command, it doesn't persist after the reboot. You have to change it in the file etc host name to change it permanently, and you have to be root to do it. The host command, simple host name IP address. So we can do a host. See, we missed it. There you go. So Facebook associated with this IP address here, IPv4, and here's the IPv6 address. Okay. Let's do host Gmail, ACCD or alamo.edu. There you go. Cool. And here's some flags to give it only IPv4, only IPv6. What type of query do you want? NS stands for name service. Okay. And then if you want to be very verbose, you want it to be not as verbose. The dig command also does a DNS query, so let's do a dig on facebook.com. Dig. So you can see right here, we got dig. IP address, the server. Okay. It's a more powerful version of the host command because it gives you a little bit more information. NetStats. NetStats are very important. They help you establish a baseline of what your system is doing, but a NetStat also assigns a process to a protocol and a port. Okay, so let's go ahead and do this. I'll type this into less. All right. So here's the type. We have dgram. Here's actually what's running, the devlog, notify, cronid.sock, notify. And then on the inode, this actually is going to be the inode section of where it's assigned to. We can find it journal, standard out. Okay. Bus sockets, journal, bus sockets. There was an X11 right there. So that's NetStats. You can do a NetStat TAC A. It gives you everything. You can do a NetStat TAC T to give you all TCP connections. There's no active internet. There's this one right here. We can do a TAC U, UDP connections. You can ask it to give you the routing table. Okay. And this is when a true NetStat is. So you can also do this. You can do NetStat on your Windows machine too. TAC ANO, all. So as you see here, I'm connected to all these IP addresses under these ports. Okay, and I'm coming out of this port here, this random high port or RHP. There are two major varieties. You can set or modify network configuration permanently. You need to edit a series of files. You can do this manually. Here are the files you have to edit: the host name for host name, host for host name IP address translation. This is going to be, to relate your IP address to a host name. A list of DNS servers, so you need to upload that. It's resolve.conf. So you can see that here. We can do a cat/etsy/resolve.conf. So here's my naming servers right there. The Etsy host file. Okay. We have the Etsy NS switch. .conf file. And this is used by application to determine the sources from which to obtain name server information and in what order. So this will actually, you can edit this and say, you know what, I want you to use this domain naming server first, okay? That's how you can edit that. Other thing is systemctl.conf, so we can do a cat/etsy/sysctl.conf, type into less, okay? Got that. The sysconfig network. So we can do that's just the system host name, specify whether networking should be started automatically during the root. We can do a cat/etsy/sysconfig/network. Actually, that's not going to work. Because this, I can't type. So notice there's nothing in there. It's blank right now. And then we can go change directly to /etsy/sysconfig/network scripts. And this is for the ifconfig. This is for the Ethernet ENP-OS3. Okay. And we can let's actually look at that. All right. So this is where the information is for this. Here's the UUID, the device. Is it on boot? Yes. Does it support IPv6? Yes. Is it a definitive route? Does it boot proto? Is it DHCP? Is it going to be static? Is there a proxy? What type is it? Okay, so we can do a change directory to /etc/network. Oh, okay. Oh, sorry. That's actually /network interface is going to be in Debian. My apologies. Again, we have the ping command. So we can actually ping. We've used this before. We're using it. We can use the ping A type actual device. The trace route command, or tracer T. This one gives you the number of hops to the next to your destination. So let's say we're doing to Facebook, okay? It's going to send a packet to every hop. It's going to say, okay, from my computer to the first hop. Does I get there? Cool. Who are you? Okay. Then it's going to send one with a kill notation of 2, a TTL of 2. So that one has a TTL of 1, TTL of 2. So it says, okay, TTL of 2, cool. First hop, we're good. Second hop, who are you? And actually, it's not tracer T, it's trace routes. Why don't I have tracer T in here? Okay, tracer T is the Windows version, not the Unix or Linux version. Okay, so you can see right here, the first hop, I went to AT&T here, 0.7 milliseconds, and sent 0.684, 0.672. That's how many milliseconds it took, and it took the average. It took all this right here. 30 hops max until I get my destination, 60-byte packets. And usually, it'll give you information of the location. So this is San Antonio, Texas, on sbcglobal.net. Notice it's taking a little bit longer to get there. It should increase over time. This doesn't mean that it never got anywhere. It means that whatever is actually handling that packet means it's filtering it, okay? So now I'm back at Washington State, Washington, D.C., I don't know. And now I've hit a NetArc Akami. So these actually must be some edge devices, some ASs, okay? And we never got there. So maybe it's 30 hops, maybe it's more than 30 hops, maybe it's actually the same thing, okay? Netcat is used for debugging. I'm not going to go into that much because it's actually kind of used, but Netcat basically you can basically establish a connection on a specific port. You can make sure that your actual connection is being established properly. IWconfig, I don't know if it recognizes. Let's see if it does. No, okay. So I can do a sudo apt-get install IWconfig. No. Get installed. Yes. Okay, so cool. So the unfortunate thing, I don't have a wireless. It's not recognizing it, but that's where you can identify information about the wireless. Wireless IW list. Okay. So that's it for the basics of networking. Again, if you have any questions, please email me. If not, y'all have a great rest of your week. And just go ahead and make sure everyone's aware of the word of the week is random high port. RANDOMHIGHPORTS. Random high port. All right, y'all have a great rest of your week and look forward to mod number 10. We have 3 more modules, 10, 11, and 12, okay? So we will also be talking on module 10, we'll be talking about the final project, all right? Final project, that's gonna be very important because you're gonna be sorted into specific groups or pairs. I haven't decided just yet how I wanna do this. You're gonna be given an actual server and you're gonna be expected to complete a specific amount of tasks on there. And that'll be your final will be consisted of two parts. The test, the final exam test, and then the hands-on piece, okay? This is gonna be the culmination of everything you've learned from the very beginning. And you're gonna be working on that to get that taken care of, right? If there are no more questions, please email me, and you can go ahead and I'll get back to you as soon as possible. If not, y'all have a great rest of your day. Talk to y'all soon.